EPC's BarChip structural synthetic fibers are an engineered copolymer fiber used as a replacement for steel mesh and steel fiber reinforcement in concrete and shotcrete. The system works by distributing tens of thousands of high tensile fibers throughout the concrete mix. The unique fiber designs, surface embossing and high tensile strength ensure BarChip fibers deliver the highest performance possible over a wide range of concrete applications. Because EPC's BarChip fibers are homogeneously mixed through the concrete, when concrete is under stress through ground deformation, movements or loading, the fibers begin reinforcing at the exact point of concrete failure, significantly reducing the risk of crack propagation. When specifying fibers, it's important to understand that fibers available in the market today vary greatly in design, resulting in different classes of fiber for different applications. International standards classify three general types of fiber for concrete reinforcement: steel fiber, glass fiber, and synthetic fiber. Synthetic fibers are broadly classified as polymer fibers, and international standards divide these into micro and macro fibers. Class 1 microfibers less than 0.3 mm in diameter are non-structural and should only be used for plastic shrinkage control, impact resistance, anti-spalling, and passive fire control in concrete. EPC's BarChip fibers are a Class 2 structural macro fiber greater than 0.3 mm in diameter and can be used to replace crack control mesh or structural reinforcement in concrete or shotcrete. So for structural reinforcing, make sure that you're getting the correctly specified Class 2 macro fiber. Fiber is added to concrete to increase its post-crack flexural strength, known as toughness. This flexural strength or toughness is measured using a beam or panel test. Because fiber performance varies greatly, when designing with fiber reinforcement, you shouldn't specify a volume per cubic meter. You should specify the minimum required post-crack flexural strength. For fiber in concrete, the standard industry performance indicator is measured by the residual strength at a 3 mm deflection, or the RE3 value. The UK Concrete Society Technical Report 34 states that a minimum fiber dosage should be sufficient to give an RE3 of 30%. Because of BarChip fiber's optimum design, it achieves this value at the lowest dosage rate and the lowest cost per unit volume in the market. In fiber-reinforced shotcrete, performance is measured with panels to determine post-crack energy absorption or toughness, and this is expressed in joules. The number of joules required will depend on the ground conditions and the size of the excavation. EPC can supply documentation from approved independent testing facilities showing their fiber can meet the required toughness specification at the lowest dose rate. In nearly every available testing scenario, including flexural performance, durability, embrittlement, and spalling reduction, EPC BarChip fibers outperform competitors hands down. Testing also proves that BarChip fibers are not affected by exposure to concrete's alkali environment, with no corrosive effects seen after 100 years accelerated testing. In exposure testing, BarChip maintains 99.8% of its load-carrying capacity after 1 year of exposure, compared to only 54% for steel fiber alternatives. And all of this is achieved with the lowest dose rate required to meet specifications, making BarChip the highest joule per kilogram fiber available in the market. EPC invests heavily in industry-specific product development, conducting more research and development than any other fibre reinforcement manufacturer. EPC's pioneering designs, materials and performance have enabled them to use the different mechanical properties within the fibre to increase the number of viable applications and deliver the highest performing structural reinforcing fibres on the market. Elastoplastic concrete, synthetic fibre reinforcement, replacing steel in concrete.